Okay, welcome everybody. So my name is Bartek Kowalik and I work for VirtusLab as a software developer. So my presentation is slightly biased towards how me as a software developer use Docker. And from my perspective, it's also good to know where did Docker come from and what has an influence on it, and what technology does it use under the hood. So I would like to start with a very not related question, but you will see in a minute why I need it. So how can you chop an onion without crying? Do you know how?
You put it under cold water.
Yeah, but then the water will, just move your onion from the cutting desk. So
You put it under the sink. You use cold water, and then you have half a minute to chop it. Otherwise, you will still cry. I know. I use it very often.
okay, so the technique used mostly by chefs, by the top chefs, is to use very sharp knife, because onion, when you cut through those layers of onion, there are two substances that are make free, and when they're mixing, they're producing an enzyme which causes you to cry. So that's why. And this question I need because I see that we tend to use some tools, but we don't know how, and I would like to share with you why Docker, how Docker works under the hood. So we will be able now to use a very sharp knife, which Docker, from my perspective, is. So the agenda for today is I would like to tell you something about it's. This presentation is like history. It has a timeline, so I'd like to tell you something about what containers are, not Docker itself, but containers as an idea. Now, how they are supported by operating system, containers itself, how do they work, how do they leverage operating system, then Docker, and some useful containers and basic usage from my perspective, from prototyping perspective, because Docker is very good for prototyping as well. So quick show of hands. I would like to ask you who of you, which of you are admin or DevOps or relating somehow to OpSync or to people, okay? And who is a developer on a regular basis? Okay, great. So I saw that the same people raise their hand twice, so it means that developers are responsible also for infrastructure. So it's very common now. Okay, so I would like to start first with virtualization, because this was the first thing that we had as a tool to abstract over the machine that we are using. So very basic. Very basic stuff, how the virtualization does the job. So there is a host machine, and the host can on host we can run multiple machines, and also there is some peripherals, like in this case internet, but we can use USB, like for example LAN, Ethernet interfaces. So it's pretty standard. There's two-way communication. So how does it operate on the very under the hood, I would say? So there is a host which has a hardware. Then there is an operating system. Hardware nowadays support virtualization like out of the box. Even the cheapest CPUs now support virtualization. So then at the hardware level, we have to run operating system. The one that is used, I mean, on servers is hypervisor, but we tend to use normal operating system. Hypervisor is tweaked so that it's able to manage multiple virtual machines. And then there is a hardware emulation, which takes a lot of computing power. If you compare it, for example, to containers, so basically our operating system behaves like virtual hardware. And there is another operating system. So as you can see, there are two major drawbacks from my perspective. One is high idle utilization. So we need to reserve RAM, we need to reserve disk space. Of course, nowadays we have this elastic disk space, which means that we do not allocate as maximum amount, but only the amount that is needed. But still, we also have to boot each operating system each time, which means that there's a lot of redundancy in our memory, because our kernel runs, for example, in many cases it's the same kernel like CentOS or Fedora on multiple instances, and it's a lot of from my perspective it's a waste of resources, of course. Okay, one disclaimer, I'm sure that you are aware that VMware is it's a company which optimizes their products very well. So for example, we can run on 8 virtual cores, we can run 12 virtual machines and stuff like that. We can allocate more RAM that is available because it will, grab more memory from least occupied machines and so on. So VMware does the job, but still we have this overhead that I mentioned before. So how we can do it better? Unfortunately, there is support from our operating system. So basically, it was more than 10 years ago, so it's very old technology from today's perspective. But they've introduced two things that are foundation under containers in Linux, especially because Microsoft has joined quite recently, and also native support for macOS as well. So first thing is how our processes are allocated in memory and what we can see from a process perspective. So let's say we have two processes, and under each we have some sub-processes. Of course, there can be more or less. And in the old fashioned, we were able to see each process from each other. So everyone was able to see others. And in order to achieve some kind of barriers, there was introduced some mechanism called namespaces. And it's not only related, of course, to a memory, but also to other components. But it's very easy to observe it in the memory. So it's like boxes in which our application is placed, and it's able only to see like a horse in a city. It has very limited sight. So it's only able to see their own children or itself. So we are kind of isolated from each other, which is good, which of course virtual machines do. Another thing is called C groups. So it stands for control groups, and control groups is a mechanism built in also Linux kernel, which allows us to assign resources to our processes. So let's say we can say that give this process like 500 megs of RAM, and operating system will keep track of how much memory does it utilize, and doesn't allow to utilize more than 500 megs. It also relates to to network traffic, to CPU, to disk space. There are multiple different levels how we can limit our process. So as you can see, we are moving towards something which is called as today's standards containers, but we are not that close. And I would like to show you as a demo, two useful commands. So, oh no, I stopped my video recording. Okay, so let me show you. I just need to find. Okay, I don't know if you are able to see everything because it runs in virtual machine because it's not built in macOS kernel. So the first command is. It's not. I think it's not visible. But first command that I wanted to show you is lsns. Yeah, but it's embedded in virtual machine.
No, I'm not talking about the size of the screen, only the size of the font.
But it's still embedded in virtual machine.
Oh, okay.
Oh, there's a scale factor. Maybe I can like 500. Ah, now it's better. Okay, so as you can see, I am able to inspect namespaces. As I said, there are different namespaces. There's PID namespaces, which is for visibility between processes. There's also mount namespace, which limits our ability to see different devices or mounting points. It's not connected necessarily to devices. There's also network. There's also network, which is visible here. So that's the first one. And the second one, which is related to C groups, it's our ability to look up how many resources are we utilize on different levels. So I don't know if you are aware of, but Linux nowadays uses something called systemd. There was a lot of noise about it a long time ago because it's a huge service which takes a lot of responsibilities. That's why Linux users tend to use small tools for a specific purpose, but it's kind of standard nowadays. Almost every distribution moved to systemd. So systemd enables us to assign resources to our processes, and in that case, we can see that, for example, our network service has 2 tasks, and in total we are using like 170 megs of memory. Also, systemd has tree structure. And under system slice, there are 2 slices, the system slice and the user slice. So under the system slice, everything that's related to operating system, like for example, network manager, or third in that view, cron. So everything that operating system is using in order to run. It's also worth mentioning that it has minimum amount of resources that it needs, so it's always operating system is always able to run even if we have a process which takes a lot of memory or, for example, CPU power. And under user slice, everything that's related to user, for example, our application, lives there. So of course, we are able to move applications between slices, of course, and assign different slices, different resources as well to users, for example. So it's a pretty powerful tool. It's very simple to use. You just everything like memory or CPU is a property of a process, so you can assign CPU to the process. I think no. Okay, So go back to our presentation. So there are two major steps towards containerization. First thing is our accessibility, is our ability to manage what we can do, and second thing is how much resources we can take. So demo. So first thing that has popped up just after those two features were introduced was Linux containers called LXC. They are not very popular right now, but it's worth noting that it was Docker's backend for like most of the Docker's lifetime. At certain point, then they moved to use their own backend because, as they said, LXC was limiting them. I don't think it's necessarily true because Docker nowadays is a company, so they're trying to force their standard, but it's up to them. But still, Linux containers are there. You can use them, but from my perspective, it's kind of a pain in the back. But why? Okay, so we have this namespace isolation. We have these C groups because this is what LXC does. It also has command line interface, so you can think of yourself. So what the heck? Why nobody uses them? Because first thing that I encountered was distribution mixing problem. So there is no simple way to run, for example, Fedora under the Ubuntu or Debian-like kernel, because there are some tools missing, so you have to install them on your own, for example, and it's only the first step. So as you can see, command line interface is very similar to one that Docker offers. So because, as I said, it was Docker's backend. So what's more wrong with that? So, for example, and it was a huge issue for me, and I moved to Docker very fast from LXC. So it's network management and configuration, because you have to manage everything else besides namespaces and C groups on your own. And as this example, it only allows you to attach LXC container to a bridge which has internet access, and it's quite demanding, especially, for example, for me as a developer, because I needed to get known to, for example, IP tables and know how to manage them. Especially, it was hard because I encountered LXC at the beginning of my let's say, career. So, and also there's an issue, for example, if you try to connect a bridge interface to Wi-Fi interface, it's also limited because you are not able to do that. So then Docker came, and firstly it was described as this, and it's one of the most misleading diagrams in modern history, I would say, because it suggests that Docker container engine is kind of a layer, the same as hypervisor, and it's not. They've upgraded this diagram to be more like this, and it's, from my perspective, it represents what the Docker truly is. So Docker is an orchestrating service. It's not a layer. It doesn't residue as a layer like kernel or something, or operating system. It's only a orchestration service which you orchestrate using CLI. Under the hood, it's a service which uses socket and HTTP to be managed. You can inspect that, for example, in the configuration. It's socket exposed as a Linux socket. It's not directly exposed to the outside world using HTTP by default. And it manages for you network, containers, images, because container is like living thing. Image is like blueprint for your service, for example, database or your application if you create one. and for example, in that case, data volumes, which is related to where you put your data. It's quite common to, for example, if you spin up a Docker container for database, you put your persistent data outside of the container, because then you can upgrade database version, but it's not also easy process, but we can discuss that offline. Demo. I'm not sure if I exit. Okay, it still records. So maybe I will ask you a question. Have you ever used Docker on your own? Please show your hands. Okay, so I'm not going to show your available commands there. I just want to, for example, show you quite a useful thing. Is it readable, especially at the back there? Okay, so I will increase the font.
You can show us a demo. We can see it. That's fine.
Okay, we can, of course, list containers that are available in the system. It's not that demanding, but the thing that I would like to show you is network interfaces. So for each unit, there is a dedicated interface created. I don't want to mention too much about Docker Compose because it's next to my slide, but there are a couple different network interfaces that are given by default. So first one is none. It's not connected to any to outside world, so it's like def null. So isolate a container as much as you can. There's also direct access to a host, so you are exposed as a virtual machine using your Docker container will be assigned with IP address from your router or something like that. And also there's a bridge interface where every Docker container that you create, like Docker run, will be connected to. There are also other different network interfaces, like this for developers 218, Alpaca default, or whatever there is. So there are more related to Docker Compose, which I will mention in a minute. So what else I can show you from what can be interesting. So for example, we can list every volume that is available, that's been ever created by our Docker containers. So as was mentioned in the previous presentation, Docker containers are immutable itself, but there are, if you introduce a change, for example, log file, or I don't know, anything that you will do on inside the container, the file system init will create small delta on top of this immutable piece, and you will be able, for example, to use docker commit command in order to save what you have done to your container. So you are able to modify the container. You are able, for example, to modify. I tend to, for example, prototype, like I create empty container with CentOS, for example. Then I will play with it somehow and commit my changes. And then, for example, I can pack this image and send it to my colleague, let's say. But it's not good. It's not very good to do because it's not portable. Of course, you can, for example, connect to Docker using Docker exec. It's different from Docker attach because Docker attach attaches to the current TTY, and exec creates a new terminal session. But those are details. Okay. So now I would like to share with you some some containers that I use, for example, on a daily basis with different projects. So first one is Mailhawk. I use it, for example, if I need SMTP. server. It's an SMTP implementation, but it's like DevNull. You can see what emails has been sent, but you are not able to send them to the outside world. It's like mock SMTP server with whole, of course, with whole SMTP specification implemented. Another thing which is very useful for me is I know that Amazon is almost for free, but if you are trying to, for example, of course it's not for free, but S3 is kind of cheap. It's one of the cheapest things that we can get on Amazon. But for example, if you want to have integration test to check if your application behaves properly against S3, there is a private implementation by Scality, S3 server, and they behave the same as an Amazon because they are private cloud provider. So they provide you private cloud. The same goes with Minio. It has more functionality because it behaves more like private Dropbox, and also exposes S3 compatible API. So when it goes to infrastructure, we have a lot of different tools, and we can just search for them. Those are containers which I use a lot, especially Kafka, HBase, and Postgres. And for me, from my perspective, it's great because Postgres is kind of tricky to set up because you have to initialize the database and so on. But with container, you just type docker run and it's boot and it's ready to operate. And also there is, for me, it's like 90% of my interaction with Docker is Docker Compose. So just jumped into demo. So Docker Compose itself, let me make it bigger. So it's a file, it's a YAM file, which contains description of services that you are using or want to use. In my simple example, it's a MySQL database with Mailhawk and WordPress, and those containers are connected to each other. And for example, Mailhawk exposes to outside world only web interface, not the SMTP server. WordPress is exposed by using just a port, and database is not exposed at all. As you can see, you can manage what things you want to expose, which ports and which not, and it's also kind of secure. You can bind them to specific ports on your host machine, but you have to be sure that those ports are available, of course. Okay, so basically you can tell on which services your application depends on. It's kind of tricky because it only checks if the container is running. So for example, if your database or for example Kafka takes some time to boot, WordPress won't wait for service to be completely booted, but only for a container to launch. So it's kind of tricky. There were some health checks, hooks, and so on added and removed to Docker Compose. But it's still kind of tricky. And for example, I use privately Docker Compose on my private server when I run some Nginx instances and so on. And just to move quickly to demo, so here is Mailhawk. I will show you in a minute. Okay, so it's just a dummy website with WordPress. Okay, so I have, of course, I have tested if I'm able to send emails, but I have downloaded dummy WordPress plugin only to show you the connectivity between containers. As I said, SMTP port is not exposed to the outside world, but it's visible to internal network. And I was able to send an email and receive that email inside another container on non-exposed port. But it's a lot of magic under the hood. And as I showed you, there are network network interfaces. So the one that is used here in this example is this one. So how does Docker operate? So the name of your service is also the name of your service inside internal DNS server, which runs under this bridge interface. It's private, encapsulated inside this bridge interface. And what it does, it allows us to connect containers by names, not by IP addresses. So it's so to be more flexible. So for example, I can show you in settings that I used just a mailhook name, which is of course not a valid host name on the internet, for example. I mean, not truly valid host name. You know what I mean? There's no domain assigned to it, and of course not exposed SMTP port. So Docker does all the magic under the hood, and those virtual interfaces, which under the hood are just simple bridges, are created for each Docker Compose file, and the same goes with every other thing that we have. I can, for example, show you that Docker Compose also has this neat feature that you can list only containers that are run under this Docker Compose instance. You can check, for example, ports which are exposed and not. As you can see, this port is not exposed, but those are this and that, for example. And you can play with Docker Compose. Basically, it's not that it's not very powerful tool, but it has a lot of useful features, especially from my perspective, where I can boot up in a single file H-based database, Kafka, and Zookeeper in order to test my application locally. Does it have any drawbacks? Yes, of course, as every tool that we use, as we discussed before this presentation. So systemctl isolation is one of these drawbacks. So if your service relies on systemctl, maybe not, current application does not relate directly on it, but if you want to play with systemctl, it's blocked. It doesn't point to any real service. And also, for example, JVM has a lot of problems with detecting how much memory does it have available under Docker container. So yeah, there are some limitations to Docker, but it's a very powerful tool nevertheless. So what I haven't mentioned during this presentation, first of all, Dockerfile. It's a standard tool to create your own Docker images. You can choose from very simple building blocks like operating system, CentOS, Debian, whatever you want. You can also create on top of like JVM Docker image, which contains already installed JVM there, so you can play with it. Of course, Docker Swarm, it's been eliminated quite by Docker Compose, but it's still there in ecosystem. And of course, Kubernetes, but Kubernetes is a tool that uses Docker in order to run. So as I mentioned, how do I use it? So tests, a lot of tests are run inside Docker, especially those integration tests, because I can, in a minute, I can create a new database instance, run my tests, and delete database instance without any effort. Of course, local development, as mentioned, and prototyping. As I mentioned, some of my privately used services, like for example, I use Redmine to play only, but it runs on Docker. So if you have any questions, I'm more than happy to answer. Okay, so if not, then thank you for your attention, and thank you very much.